How we doing, folks? Not been here for a while. Well, the jobs get in the way, but trying for Tiger Cub, we're going to go for the excuse me, 6 to 12 volt conversion. So original stator and rotor run on a 5/8 shaft, and the 12 volt version rotor runs on a 3/4. So there's a sleeve that you can get, part number E4454, which will convert your 5/8 old rotor shaft size diameter into 3/4, which will fit a Lucas RM21 rotor. So that bit is solvable, and the actual stator. So I think on the very early Cubs and definitely the Terriers, but the ones where the casing is narrowed down in this area, so where these studs go, the screws go, it's a lot shallower. I'm not sure if an RM21 rotor would actually go in there, but definitely on the later versions, and definitely on the side points version with the oil end feed to the crank, definitely. So the old rotor out, and what you're left with, you've got the 5 studs, but there's actually a post with no stud in it just here, so like one of these posts but no stud hole in it, and it's just like where the rotor would rest. And I think maybe the wires might come out on that side on the early rotor, I'm not sure, because this engine didn't come with the old rotor. But you've got to grind or cut that post completely away, because obviously this is quite thick on the back compared to the earlier model 6 volt version, and it'll sit on that post and won't sit down. So you've got to make sure that you take nearly all of it away, because these are quite fat compared to the earlier versions. So obviously I've already done this. Bit of a cheap route, nice with a die grinder if you've got a die grinder, but I used the 4.5 inch angle grinder, and I wore the blade down till it was quite small, took the guard off. Shouldn't be taking the guard off, take care, but you can actually get in then and you can grind that away. But if you've got a die grinder, obviously it's nice, probably get a better finish. But yeah, it's out, good job. So that now will sit down flush inside there, so you end up with the cable coming out this way, and with that at the top, and that now I have tried this on once, and it does sit on there. So they are a bit tighter than the original one, but they do go on, he said. Yes, so it's sat down. I did put a dentist mirror under there to make sure that it was sat down flush on these, and it is. So I'm just going to pull that up now, and then this side of it is actually done, and then we can have a look at what we've got to do with the crank end 5/8 up to 3/4 with this adapter. This is because I've done a couple of these, so there is, and they were different as well. No two things are the same on these old BSA and Triumph bikes, but there you go. But it makes life very interesting all the same. So obviously these are BSF. Unfortunately, unlike the later C15s, the B40s, B44s, Starfires, B25s, C25s, and the Triumph equivalent, which was the TR25W. Let's wind this in. They all mount directly on 3 posts, directly on the engine crankcase, which makes life very easy. There's a few downsides to having it fastened on this casing. So this is off a B25, and this would sit on here, and you get the advantage then, because the studs are on here, you can have the tensioner, which you obviously don't get with a Tiger Cub, to be able to pre-tension the primary chain. There is a company that does sell this as a modification, so they fit the 3 posts on here to allow this to be mounted directly onto this crankcase, and it also then gives you the ability to be able to use a tensioner like they do on the C15s, B40s, etc., to keep the correct tension on the primary chain. Unfortunately, you don't get that option with the Tiger Cub, so it was all down to keeping the engine as light as possible. But there's a few downsides to it, because it always advises you when you're fitting one of these, you're supposed to have like a 10th thou air gap all the way round between the stator and the rotor, and you can play around. In fact, what I generally do is I put a few turns of masking tape on the rotor, fit the rotor, it's on a C15 or a B25, etc. Then when you fit the coils on the outside, it positions it exactly in the middle, because there's a bit of leeway or slack on the studs. Then you can pull it down, tighten it up, then you can pull your rotor out, take the tape off, and you've got that beautiful air gap that's even all the way around. You obviously can't do it with this because you can never see it. So anyway, that is that fitted in there, and then a bit of a cruel, torturous turn, but you give a dead 90 turn on the cable, not with these connectors, but going to lob those off. These come in different variations as well. Some have got a gland, some have got a grommet. This thing's got like a little bit of an extension of the casting on the inside. Well, that would feed through there. If you've got a gland, obviously tighten the gland up. If not, a bit of silicone maybe to keep the moisture out. I don't think you're going to get oil throwing out there anyway, but yeah. So that's our stator fitted. So let's have a look at the rotor. So Lucas RM21. So you've got a date on this one, 10th 1969, and this is brand new. Both bits are brand new, new old stock. Now we are TR25W, so the 250 Trailblazer or whatever guise it came in of Triumph. But yeah, brand new. So I didn't have the original rotor for this, so I can't show you that bit. But what's on there is there's a sleeve on here that packs it away. So, and the sleeve's held with a woodruff key, and the woodruff key also locks the original stator. Obviously there's no way that's going to do anything like now with any of the stuff that's on it. So this comes off, and that now becomes redundant. The woodruff key comes out. So let me get a pair of pliers for that. The original woodruff key comes out. And on some, I think all the crankshafts, there's actually 2 woodruff key slots. I think because some of them had the ability to, like the Trials version or whatever, that you could have without lights. So you had an extra winding set of field coils, so the bike will run without battery power, etc. And then the later versions, obviously without. So there's actually 2 rotor positions. It's obviously irrelevant now because obviously we're not going to be having emergency ignition running without a battery. This thing now going on to 12 volts. We're either going to need a capacitor, you know, a battery slave capacitor, or a battery. I generally fit a battery. I just like it, but some people go for these big capacitors. It's a battery saver or whatever you want to call it. So anyway, with this part number E4454 sleeve, you do get a woodruff key which is bigger than the original, in the fact that obviously the width and the arc is the same, but it's physically taller and slightly longer. So that would go in any of those positions. And then this sleeve now, I'm just going to tap that in a tad. Should slide on, he said. Just need to tap that down a little bit. The woodruff key is just twisting upwards as I slide it on. There we go, we're on. So with that in, because this woodruff key is a lot bigger and taller than the old one, not only does it lock the sleeve in place, but it also now leaves at least half the woodruff key sticking out this side to pick up on our RM21 rotor. So now that will locate on that woodruff key, and there we go. So we're on the way. I put that on the other way, not that it matters because you have to ignore the timing marks. The timing marks, we did a previous video on marking one of these up and making a little bracket that will go on here so you can strobe the bike out up. If you take this cover off, run it on the battery, you'll be able to strobe the timing, because we can now put a new mark on this in relationship to a bracket that you make. And obviously you have to ignore anything that you would find on a C15 or a B25, B40, etc. But that will now sit on there. So I'm not sure about the original bolt that was holding it on. This was already just screwed on the engine. Obviously not enough threads on there. So this is an original 5/8 shaft Tiger Cub rotor nut, which I had in the box just as a spare, and that just so happens to fit nicely inside that sleeve. So when you pull it up, you're going to push the rotor against the back of the sleeve, and the nut is going to go, or the shank of the nut will go in the unsupported area of where the threads are, making it solid. So that's how that ends up. But there's one thing I'm going to do just to make it, and I did this on the other one I did as well. You know, it probably would be fine, but you're left with, because this sleeve is probably about 20mm short inside there, you've got an overhang here which is unsupported. So what I'm going to do, I've got a bit of 3/4, just to take a light skim off that, got a bit of 3/4 or 20mm, it'll be a bit of 20mm round. I'm going to turn a bit of 20mm round up. I'm going to bore the centre out so that it fits on this nut and sits down the bottom there. So this is supported all the way. So that's one thing I'm going to do before we go any further with mounting this. But we just have to make sure that the flux of the magnetic field is central to the stator. So what I did, I put a straight edge across the face and I measured halfway, so I'm right in the centre of the field coils, and I get 30mm, actually 28mm to the centre of that, where the coils would be wound around that post on there. So we need to have similar here. So again, if you put your straight edge across and then go off the straight edge, we want to see that we've got our 28mm, and it's actually, this one's 20, it's 25. So just going to check it a little bit more accurately. 135. So that's 34, the total width. So if we went 17, we should be halfway, shouldn't we? $17. So if I just get a Sharpie and mark that. So that's my halfway. And we're looking at 28 So I need to take, got to take 2mm off that. That's 25. So just let me recheck the halfway point on this. .28. So, and what I'm going to do is I'm going to shave a couple of mil off this sleeve. So I've got that magnetic field exactly. Oops, there's the key. Gotcha. So I'm going to take 2.5mm off this face, which will bring that rotor a little bit further that way. So I've got the magnets exactly centered with the magnets on that one. So just while we're talking about this rotor stator, RM21, so 12 volts, it's 10 amps at 12 volts or 120 watts, or whichever way you want to look at Ohm's law or whatever. So you also need to procure one of these. So I think the last one I fitted, I've used Lucas and I've used Podtronics. This one's got no markings on it at all, so this is probably an eBay China Boy special. Still going to do the job, no problem. But if you're getting one, obviously it's a 2-wire stator, so you need a 4-wire rectifier regulator, and these are dead simple. So red and black, negative and positive, so onto the frame or onto the battery directly, negative and positive. You don't need to put anything in between it. You could put a fuse if you wanted to, but 120 watts, yeah, probably in case we did have a disaster. So it was nice to have a fuse there, isn't it? Just in case something fails on this and sets the bike on fire. But this side, the rotor, the 2 yellow wires, and if you buy them off eBay, because I've fitted them to a few different bikes as well, sometimes these are pink, sometimes these 2 wires of the same colour are the ones which connect directly onto the coils of the stator. These are both marked the same, green with a yellow tracer, but obviously because it's a sine wave, you know, starts off 0, positive, 0, negative in a cycle, dependent on the number of coils and how fast the engine's going. It's irrelevant which way round you connect these cables, because obviously this is going to straighten out into DC, but obviously you need the red to the positive on the battery and the black to the negative. So I think the 15 quid or something for an eBay special, or maybe 25 quid for a Lucas, or 35 quid for a Podtronics, dependent on what quality. But obviously it needs to be 10 amps minimum, because it's a 10 amp stator. So that's where we are. So the next job now, I'm going to switch us off and we'll reduce this by 2.5 to bring our magnetic flux directly in the centre of the field coils. Got a bit of 20mm. I'm just going to bore the centre out and part it off so I can make this nut into a shouldered nut so I can support this stator right at the end, because it's not supported fully on this, because this probably only goes through about 3/4 of the way. So nice just to have it fully supported. And not that I'm going to put a lock tab on it anyway, but if you didn't put something to make up that diameter between this and this, you wouldn't be able to use a lock tab, because the lock tab's got to sit in there and obviously needs to be constrained within that distance, but that's only 5/8 and this is 3/4. So by making a sleeve you would be able then to use the standard C15, B25, B40, etc, lock tab. But I don't generally use lock tabs. I just like to put a bit of Loctite on there and wind it up. So I'm going to cut you loose while I just make a mod for this, knock it down and make a collar for this, and then we'll see you in a short while. Okay, so we've removed our little bit of material off the end of the adapter, so that now when the rotor butts up against it and it's pulled up, the magnets now line up dead centre with the stator, so the field coils of the flux or whatever are all perfectly aligned. So also we've made our little 7mm long adapter with the same outside diameter as the sleeve to fit the rotor, and same ID. So now it will be supported along its whole length. But there is an issue, as there always is. Let's nip it back together and I'll just show you. Sleeve on, rotor on with the woodruff key lined up, the sleeve goes in, the new sleeve and the nut. So we're now fully supported along the whole of its length. So I'm just going to nip this, and I'll just show you why I'm only going to nip it. If I hold this still now with a spanner, I can move. I don't know if you can see that, but I'm holding the nut still, or I'm stopping the crank from turning, and the rotor is actually moving back and to on its internal sleeve inside the aluminium. This is a brand new, okay, date stamped the 10th 69, so as brand new as you like, new old stock. Never been on a bike before, brand new, and that rotor is moving on the steel insert, and it's not an uncommon thing with these. I've done a few of these in the past, but I thought they'd have a few thousand miles on them before they fail, but it's obviously been a design fault of Lucas, because that's never been on a bike and it's not bonded properly. But if you can see, this is off this engine here. This one was actually loose, and I was going to see if I could find another one, but 9 times out of 10 on an old bike, especially on the singles, because I think there's more of an inertia jump on a single cylinder than a twin cylinder. You know, it's a little bit more kinder on the rotation of the engine from firing. But this one was actually loose as well. So what I did, I drilled halfway into the steel and halfway into the aluminium on both sides, probably about 20 mil deep, and I've put 4 and tapped it. I think it was BA or whatever grub screws I had, and I've tapped it. I think it's 2BA or 3BA or something, whatever cap screws I've got, and then Loctite and cap and grub screws in there, and it's lock solid. So obviously now I've got to do that with this one, but the exercise is done. The RM21 stator is fitted by grinding our little post off, which allows it to sit nice and flat. We bought our small adapter, part number E4454, available from eBay, Meridian, Vect, lots of different places sell it. Fitted the rotor, got our depth, because they're all, I have recently done one of these before, and they are all slightly different, whether it's the maybe different sprocket, I don't know. But the last one I did was I converted it to side points, so the original engine would have been a distributor engine, but so they all might be slightly different, but you have to check. So took a little bit of distance off it to centralise the magnetic flux, and made my little extension sleeve so it's supported along the whole of its length, and I would normally just fit these with Loctite. Obviously I'm not going to do this now because I've got to take this off again now and repair this. But yeah, it's a simple job, and then the only other thing is you need to treat yourself to the silicon regulator rectifier, and then while you're doing it I would definitely go for negative earth on the bike, so I can fit LED headlight bulbs and all that stuff, and there you go. So unfortunately we nearly made it, but yeah. And it fits obviously, so nearly there, but yeah, possible. But it's a nice little modification, and then it simplifies the wiring as well. You just bin off the plate rectifier and the Zener, it's got a Zener on it or whatever, and very simple wiring now, only 4 wires, and then just from the battery, inline, ignition, lights, whatever, you only need a single position switch, and a simple, nice and effective mod. apart from the stator failure and the rotor failure, which we've now got to look at. But anyway, job done, and see you on the next one.